Okay, class, this is the video that we are going to go through assignment 10A for some students who need it. All right, okay, so let's start with assignment 10A MCQ questions and the structured question. First, let's look at the first question. Which of the following pairs are members of the same homologous series, which means the same functional group? So if we're looking at the same functional group, you can see that the first one is an alcohol versus an aldehyde. Second, you have an alcohol and an alcohol. A third one will be the ketone and the carboxylic acid. And the fourth will be a ketone and the aldehyde. And therefore, the answer for number 1 will be B. Question 2. Which statement is correct about a Lewis base? Now, we all know that Lewis base is a proton acceptor. So in order for it to accept a H+, we will need the Lewis base to have a pair of electrons. Something like this, right? Now, so therefore, it's an electron pair donor. So that will be option A and C. And being rich in electron, it will be attracted to positive side, and therefore it will be a nucleophile rather than an electrophile. So the answer for question 2 will be A. Next, we will move on to question 3 and 4. Which compound is an amide? So an amide, it has a functional group that has this amide bond, which is CON bond over here. And this could be N or H and R. So we are looking for this amide linkage. And then if you draw out the structure, you will find that it's B. Now, why is it not D? Because if you draw out the structure for D, right, it's actually a carboxylic acid. The NH2 group and the CO are not linked together. So answer is B. Question 4. What is the name of the ester form when this react together? So when we name an ester, we name the alcohol portion first, followed by the acid portion. So if we look at the alcohol portion, it's a methanol. Methanol. So it must start with methyl something. So therefore, answer is either B or D. Then if I look at the acid, we have 1, 2, 3 carbon. So therefore, methyl propanoic. Answer is D. All right, so the same idea is applied for question 5, propyl propanoate. But the thing is that when you're looking at ester, you need to cut the ester. Now, how do we cut the ester? Usually, if we look at the ester, we have a COO, we will have to cut over here, right? So if we do that for every of the answer over here, we'll find that we'll cut our ester here, and this is not even an ester. And of course, this is not even an ester. So its answer will be either A or B. And we are looking at a propyl group with the alcohol. So a propyl group with the alcohol means that the alcohol has 3 carbon. And you look at this, alcohol has 2 carbons. So therefore, the answer is A, question 5. Okay, question 6 again is an ester. So if you look at the structure of the ester, the same way we cut up the ester at the COO. So once you cut it up, you count the number of carbon, 1, 2, 3. So we know it's a propanol. It came from a propanol. So we need the name to have a propyl something, right? And then propyl methanoic. Answer is D. Question 7. Now, question 7 is about boiling point. So I'm looking at them and they are having the same intermolecular weight. So this question is clearly a question of surface area, straight chain versus branching. So when there's a branching, it actually decreases the London dispersion force. And so it will be weaker. So the one which has the highest boiling point must be the one that has the least branching. So answer is C. Question 8. Which of the following substances are structural isomers? So being isomers, we need to make sure they have the same molecular formula first. So if we count the number of carbons, we can briefly check it's about C5, C4. In this case, it's only C5. This is C4. This is C5. So first thing, we must make sure that they have the same molecular formula. So you don't find the same molecule, you don't find the same molecular formula at all for number 2, right? So then we look at the rest, we draw out number 1 and number 3, and you'll find that they're structural isomers. So how do you draw out number 1? Number 1 is a CH3 bonded to a CH2 3 times, another CH3. Okay, number 3 is you have a CH3 and you have a CH, and this time this CH has another CH3 group here, and then we have a CH2 and CH3. So it's a form of branch isomer, chain isomerism, sorry. Okay, next question, question 9. Question 9, answer is B, which has the lowest boiling point. So, which has the lowest boiling point. So question 9, the answer. Sorry, question 9, the answer should be C. All right. Now, so this is containing hydrogen bonding. So they will tend to have high boiling point. So we have this over here, which has London dispersion forces, but you can see that C is highly branched. Yes, 3 methyl group attached to it. So it will have the lowest boiling point. Now the next one, question 10. So we're going to look at the functional groups. So let's check the answer. The answer for this will be, you have a ketone. Sorry. Of course, we can see benzene. And now we take a look and we can see an amine. So answer is A. Question 11. Okay, question 11 is a example of homologous series is alcohol. Describe 2 features. So for homologous series, right, we need to take note that they differ by a CH2 unit. They have the similar chemical properties because they have the same functional group, and they will actually have different physical properties. Example like the mass, density. All right. Okay, so that will answer the question for the 2 features of homologous series. Next, we are looking at the IUPAC name of DEFG. So let's look at the name of the DEFG. So first, maybe you would like to sketch up the structure. Our D. So this carbon over here is bonded to 2 methyl group. Okay, so our longest chain is this over here, right? Highest priority should be given to the alcohol because it's number 1 in this case. So this is a 1, 2, 3, 4, 5. So it's called a penta 1 or. So 2, 3, 4, and so we have a 4 methyl. Now take note, number 1 is given to the alcohol because that's the highest priority functional group. That's for D. Next, let's try to name E. So the same thing, if you draw out E and you sketch it out, it will look something like this: CH2, CH2, CHO. So this is an aldehyde, and it's the longest chain. 5 carbon aldehyde, so it will be called a pentanal. There's no need to tell me penta 1 now because default 1. So it's called a 4 methyl pentanal. All right, that is for E. Now for F, so if we sketch out F, you'll find that it's a carboxylic acid. So it's called pentanoic acid. And then we have 4 methyl pentanoic acid. Okay, next one, That's all right. Okay, there's a G here. G again is an ester. We can see over here the COO group. So we need to split up the ester. So as we split up the ester, so let's count this part over here. We have a alcohol, 5-carbon alcohol with a substitute one, I think. Okay, so that was from our this alcohol. If you remember, it was from our 4-methyl penta-1-ol anyway, right? So it will be called a 4-methyl. It came from 4-methyl penta-1-ol, so it's called 4-methyl pental. That is the alcohol part of the ester, and then the acid has 2 carbons, so ethanoic. All right, 4-methyl pentyl ethanoic. That's the name for the BEFG. Okay, next, the boiling points of the propanes are shown here. So we can see, identify the boiling. So this again is about extensiveness of branching. So the least branch structure will have the highest boiling point, and the most branch structure will have the lowest boiling point, and so this will be intermediate. So identify and state a reason. So over here, the reason is about increasing in branching. Decreases surface area and weaken the London dispersion force. All right. Okay, now we're going to name B and C. So again, if we look at B, the longest carbon chain is something like this. And number 2, there's a methyl group over here. This is the methyl group. So it's for B, it will call it 2-methyl butane. And for C, right, you can see this is the longest chain, which consists of 3-carbon propane, and on number 2 there are 2-methyl group over here. So we have 2-methyl groups, so we call it 2,2-dimethyl. All right, and that's for this question. Let's move on. Oh, that's all. Okay, that's all for assignment 10A, and then we will go on to assignment 10B in a while.